Anyone who has found mistakes in my counting? And John and Abdul and John. Did I update your stuff? Who is John? I have. I wrote and said, can you confirm that I have updated? You just say that to everyone. You only asked. You said I remind you, I've reminded you. You said I've updated, can you confirm? You can go to your whoever supplied this job should be in prison. These days I'm very careful when I'm saying things because they happen. So I'm very careful. I did this as an example. I said it in a test. Some people came to ask it. I almost changed, but I said anyway. Since I didn't do the number completely, let me still bring it. But it will never happen again. If people ask me something that I have said, I will change this time. So this was a current source. Is integer here? It's integer. How do I give you paper nicely cut? And then when you are drawing a circuit, you draw like this. Like you are sketching fine art. I'll start meeting some of your parents. Allow to know whether it is your fault or their faults, in one way or another. Because sometimes I'm not getting it. So we got point A here. Kilo ohms. Then the points where we needed I for were points A and this was point what? Point 1 kilo ohms. When you are writing kilo, these are things that you take unserious, but they are serious. When you're writing kilo, then it is this small k. So this is kilo ohms. If you say this one, this is Kelvin ohms. If you are supposed to be saying milliamperes and then you do this milliamperes, this is mega amperes. This is 10 to the power 6 amperes. Milliamperes is this one. Yeah, so we go to, is there a resistor here? Here? No. So we got R2 here, this is R1. R2 here, this is how much? 2 kilo ohms.
This is 3 kilo ohms.
3. And then this is 2. asking like that, I want us to own it together. And so this is the point B, and this is R3, this is R4, and we are asked to find I4 using 1. I don't think it was 1, but it was one sentence. Superposition principle. Actually, I wanted to make you use everything. Kirchhoff's, superposition, and Thevenin's, and then Norton's. Please be attentive. I only have an hour or less now, so that you get this for now. And then I'm thinking of making, if you have seen that video, I'm thinking of making those short videos of explanations of different numbers for future generation, not for you, for future generation, so that my reason why I chose to do physics and remain in teaching is because of the teacher who told me, and he was always busy saying, you cram, you go to Makerere and understand. I came here, I didn't understand. But even before I came here, I made a promise to myself. I will understand things from Nelcon, and when I'm a teacher, I'll teach my students to understand. And if they want to understand, you know, these people who teach a small thing and then the exam is very hard, or the test, they just do that small example. And then it's like you go and now hustle. Mine is to do the hard stuff. If you want to add on, you add on. But go when you are empowered. So, by superposition principle, it states that you first make sure that you remove you take a source at a time. So you can remove a current source by removing it, in a sense. You remove the current source by removing it. You remove a voltage source by short circuiting it. Because if you short circuit a current source, at the same time you will bypass the resistor which was across as the current source should be. Because the current source is a current source, and it has to be in parallel with the nano resistance of that supply you are considering. If you short circuit it, you would have also short circuited this resistor, so you would have missed another component of your circuit. So current source, so in brackets, I do this. These are not part of the text in the book, but these things will help you. So in this method, and I'm teaching in a university, so I can do my own rules. You know that? I want you to have that freedom. Some students think I'm bragging, but at the end of the day, I'm just trying to make sure that you become independent. It's about us. Nobody is going to come and say, hey, you used to say this. It doesn't matter. We agree on what we want to do to make our life easy. But when you are teaching secondary, that's why I left that place. You teach. The director is on your case. The students, they also want to pass. If they pass, they are smart. If they fail, you are not a good teacher. It doesn't make sense. But here, so in this method, we take his method. Does it have E or no? No. Now which no? We take this method we take or we look for the current. We look for the current contributed by each source at a time. So what does this mean? This is what I want to explain. At a time. So a voltage source is removed by short circuiting it. Whereas the current source is removed by removing it. So I don't know how I termed that one. It's removed by removing it. So by removing it. It's removed by removing it. I don't know how you're going to understand this. This is just for purposes of understanding. It's remove.
Okay, I think what you said by opening circuiting it.
Opening circuiting it.
Yes.
Okay, thank you. So by removing it in quotes means someone says, let's be practical. This is the same as open circuiting it. Open circuiting it, that one is open. No problem. You see, when I was doing PCM, some guys never used to bother about the English. Because I got English, D1 in English at primary and in the village, I was more cautious about my English. But it was okay. If you tied a buffalo, they will say that is a Messiah. Like you do PCB or PCM, it is okay to tie buffalo. But I don't think, have I ever tied a buffalo in the lecture? I may be tying them and you just look at me and Alex, you bring your phone here. Quickly. Boy. You will thank me later. I hope you have brought the one which you are using. Put here where it's clean, so that I don't. Are you sure you first switch it on? Because you are switching on when you are all on it, you bring the one which you have. Both of them. Put this one there and bring the other. Because it is not on. You can't be on the phone and then when you bring it, you are switching it on, you bring the other one. Both of them put them in. You thank me later. Open the circuit again. Because I don't think you are on Sisi. I know you tell the truth. Is there another phone or not? Eh? There is another one. You see, you cannot tell the truth when you don't when you don't mean it. So there is another one.
I know he has one phone.
So let's I don't care how you take it. This is my class. You're gonna do what I want. And yeah, I'm not complaining. He has improved. When I would be supervising, this fellow would look at me in the eyes. It's like he would want to take my soul. I'm there, he just looks at me. Is that how you used to remember stuff? Or? So we shall, which one should we remove first? Then add the other. So open circuit, that's what said. So we shall grab here and remove this, all those connectors in the lab. We shall pull out this connector, and we say hell with the current source. So we remain with this circuit. This resistor here. In this method, the resistor near where the current is going through, we have no problem. This method, it is the Thevenin's where we shall first keep this resistor here. Then we start now looking. So let's first do this. And then we have the one which is having the current with one, the R2, and then the R3, and then cut the voltage source here, and then we add on when we have removed the other source. So here we get a connector, we push in here. We get another, the same wire we connect it to the other connector. And that's what we mean by short circuiting. It is bypassing. If you steal something with a friend, then when you keep somewhere, they short circuit. They go and pick it, they call it short circuit. Like cheating you. So we cheat this thing and keep it away. And so we have the current source is in this round. We have the resistor here, R1. We have the resistor R2. And this is the R4. And then we have the R3. And there's no source, it's a line. We have put this wire connecting here. This is the second part. This is the first part. This is what we did to the circuit. We chopped here and chopped. So we got the 0.8 kilo ohms, 0.1 kilo ohms. We need the I4 prime, and then we have the, let's keep them flowing. This is 3 kilo ohms, and then this is 2 kilo ohms, and this is 21 volts. This is 21 milliamperes. This is R1. This is 0.8 kilo ohms. This is 0.1 kilo ohms. This is I4 prime prime. This is R2, 3 kilo ohms. This is 2 kilo ohms. And this is R. We have done the basic. And once we have done the basic, we look for the current I prime 4, I prime 4 and I prime 4. Thus, for this moment, I4 will be the same as the sum of I4 prime and I4 prime. Now, to find the current here, that means we first get the total resistance, get the total voltage we have as our source, divided by the total resistance, then we get the total current. After getting the total current, and then we see how much of the current splits to this side compared to this side. So it's like we get, of course, the current that will be produced here, the total current that will be produced here is current divided through here and through here. But these are in series, they have the same current. But when you are looking at what split there, you add them because they are in series. So when you are looking for the total current, these are rules. The rule is that start from far away from the source, whether current or voltage source. So don't start from here and say these are in parallel, then you treat them as parallel, you get effective. And then these ones now is in series with this, that's wrong. Start away from your source and keep coming slowly, adding up the stuff until when you reach the source. When you are attacking an enemy, you start from the full soldiers until when you reach the commander. If you are lucky. You don't start from the commander and you kill him and then you start killing this one. By default, the commander is hidden far away from the attack. So I'm sorry to use, I don't know why I use soldier theory. I'm not a soldier, but I find it easy to understand. Because some people take it to be complicated. The same thing here. We already know that we have this current which is dividing itself around here and around here. But then whatever goes through here can be formed by knowing how much was repelled by this. But remember, whatever is repelled by this is divided by the total, so you have to first get the total, and then you have to start from far away from the current source. Do I need to do this again? Yes. Okay, since this is online, I'm trying to just look at the, but to me this is like a tutorial session, just to make sure that you get a feel of what is going on. So I'll take off this part so that we're able to find out. And the same number, I think, is the time I did it, the video is on. Maybe some of you don't know where to find it. When you open Mwere and you have clicked on the electronics course, there are 3 links. Okay, there are 3 blue stars. One is about the form which you are supposed to fill, and I think which some of you have not filled up now. Then there is an archive of those of 2024 from the beginning to the end, up to the final examinations, and then ours, which I keep adding on. I have already added on the one for test. I added on the one which I did correction the other day. I added on this Tevenins part, which I did freestyle using a marker on the whiteboard. And it wasn't perfect, but I want to make some perfect of those. Simple principles, short videos, people love them. And so, I4 prime will equal to what? So it will equal to whatever will be coming this side after we have known how much is coming from this source. So let's first get the resistances. Resistances, I really don't have time to do one at a time. So R1 is in series with R4. I had them labeled R4. This is R4. So it is this how they make series, or parallel is this, or this will also be parallel?
Parallel is what's called.
Okay, so like I said, we agree on what we want.
Yes.
So R1 is in series with R4. Then these two are in parallel with R3, R2. And everything at the end will be in series with R3, this one here. Does this language make sense? Once I have that one, then I can find the current flowing from this. After I've gotten the current flowing from this, then I use a current divider, because we want the current. So this is 0.9K or 0.8 plus 0.1 K times, because now it is in parallel with the 3K, times 3K over 0.8 plus 0.1 K plus 3K, and these ones are now in series, so I add on 2K ohms. So how are we calling this? Effective resistance. R effective. But you could, I'm trying to rush, but you can do one at a time, okay? In your free time, because I can't do one at a time, we don't have the time on our car. So R effective, those who have calcs, I forgot something. Those who have calcs, if you have the phone, you just make it landscape. Scientific data will come. 2.69 kilo ohms. So the I effect I in the circuit will be the same as 21 divided by 2.69 kilo. So this would be, you can say milliamps for now. I equals to 7.8 milliamps. This is the current I is equal to 7.8 milliamps. It is this current that will divide itself to a current through here, whichever name, whichever value it is, and then the other one comes here, flows down here and comes here. These two resistances are in series and they are contributing to the division of the current that passed through here. Don't say that because they're in series and the same current goes through in series, so can't we just say that we just look at it as the same current? The resistance, if you have one child, it's Mary, whichever dore or whichever toy you bring, the child is fine. When you got two, if they are same sex, you fight for the same doll. They are relatives. If it's a boy, they fight for the same toy. If if they are different sex, then you gotta take care of both of them. As one is playing with their toy, the other one plays with their doll. So it becomes a hassle. It is more, economically, it is a more hassling thing. So much as we are looking at this being in the cities, but having the same current going through, but they are offering a resistance that would push a little bit of it to go through. And because when we are looking at the current divider, if we are looking for the current going through here, the numerator is the one which pushed that one to go there. It's the one which go out, then over the top. So I got this, and this one is no problem. By the time it reaches here, it has already done its effect, so we don't care about this one. So now we have the I prime 4 would be the same as the one which pushed out, so which is the 3K. So we have a 3K over the total of the 3K and these 2, or 9. So this is over 0.8 plus 0.1. I'm leaving them the way they are here so that we will add finally to avoid assuming. Instead of using a calc, you may look at a 0.8 and a 0.1 and your mind just says this is 1, like as if it is a 0.2. These are things that when your mind tries to make you do things quickly, you tend to make a mistake, but only you realize after. So that's why I'm writing them as 0.8 plus 0.1 and of course plus the 3, and all of them are K. And then I will multiply by the current which we are splitting or dividing, which is 7.8 milliamps. If you want, you keep it there. In physics, no problem. You put your units there. Eventually, when you want to transform to the right unit, you transform to the right unit. Those who have calcs again, 6 milliamps. So this is my. The take home on this part is when you are dealing with the resistances and you are adding them to get the effective resistance, especially for this voltage source which you now want to use to divide by the resistances to get the current that will be divided later. Bring. Got you. Bring. It's just busy like this. I normally see some news on the phone while driving. I don't know, once I enter the vehicle, my phones are in jacket. I don't want to go to hell. Because when I enter my vehicle, I'm already in my grave. So I don't want to add on another burden of going to hell. When I park at home, I just stretch, I say, thank you, God. But when I enter my vehicle, it's a rule. From the time I bought a vehicle, when I enter like this, I'm in my grave. Because you cannot be careful on the road. Some fool will just come and go with you. A truck will just sleep on you, like that fella who had just gotten a new, I think it was either a Subaru or whatever. He was even, I think, enjoying music. A truck with the motor came and said, okay, you borrowed the vehicle. I don't care how people take it. It's a grave. You can't say I'm driving careful. And for me, when I'm on the road, it's up to me. It's about me. I just go. If you just say this fool is driving carelessly, you remain careful. So then we go to the so this part here has given us 6 milli. So we now going to look for it. So we do the same. This one is producing a current. This current reaches here, the split signal, the I4 prime which we want, and and some part of it goes to R1. And of course, this I4 prime prime also splits here and splits here. That's none of our business. We just want to know what is. So we start from this side. And here we don't need to do any calculation. We just need to know the splitting. So the calculation we need is just to know the resistances. So I4 for I4 prime prime, we need the R effective, but not in, I don't know whether I should put R effective, because we don't need the R effective. We only need the current, which, these two R effective. So I don't know what I should do. I don't know which name. So I'll just say R3, R2 is parallel to R3. And so which is equal to 3 by 2 over 3 plus 2 kilo ohms. And this is equal to 1.2 kilo ohms. So once I get this resistance here, it becomes in series with, because I told you you don't say this one and this maybe are in parallel. Don't hustle in the middle. Start from the foot soldier this way. Chop one after the other. Until when you reach the what? The commander. Then normally commanders are better humble once they see nobody around. They put up their hand. And they are even willing to give you to just tie up and they walk with you because they know the consequences. Okay? So then we have the 1.2 with this one. So R4, so this one is
R4 is the same as
R2, 3. Okay? Effective of R2, 3. Okay, so R2, 3 is in series with the R4, and this gives us the 0.1 kilo plus the 1.2 kilo ohm. This is equal to 1.3 kilo ohms. And I don't know, I should call this R23. This is a university. You need to have that freedom to define the way things are done. Follow my things, but also have freedom to define them. One of you, when it was Thevenins, they now changed the resistor up there. Don't look for problems. They somersaulted the circuit, and now the gap was up there. I think it was more appealing to see the gap from above, as if they want to pour water in. I find it very crazy. So now that we got this, the current that will go through here is the current rejected by this. So this is the numerator. So I prime 4 will equal to the 0.8K over the 0.8K plus 1.3K, and then we multiply by this one, which is trying to the source, our current source, which is providing us the current, the 21 milliamperes. This is a K, these are added, so the K goes, so I don't know, this is, so calcs. 8. 8?
Yes.
So this one here was going this way. Part of it we found was going this way. This is up there. So we need to know the directions properly. I don't know whether you gave me the right directions. Okay, so if the voltage source is going up, where would have the current been going? Yes, it should have been going down. So that means in the way I was working, one of them would be negative. So you'll work on that. You'll try to go through again and be comfortable with that. So that means the sixth one, this one here, according to the diagram, it should have been going, this one over the 21 should have been going this way. Are we okay?
Yes.
Semakula. Are we okay? About what? Because it's like these MPs who are sleeping and then say, those for nice, those who, then it increases the heart. It doesn't even know where we are. Semakula, you were busy dozing and when I say Semakula, I say, yes. I don't know, please, take this degree serious, okay? It's a job. It's a job. Take it serious. Your brothers and sisters may be showering praises on you and like, hey man, you are in campus, Makerere, how is it? You are a great man. And when you reach home, you are the big boy. My friend, these things will humble you down, okay? When you reach home, get your books to winner. Don't also start saying, hey, let me watch the news. You just say, you like campus, we don't hustle. My friend, we used to go to the dining hall and even remove shirts in the night. Because when I was in A level, one of our OBs came and they told us, you people, when we were at campus, we were doing Bachelor of Nursing. Not nothing, but nursing. He told us, we go to the dining hall and read and even remove shirts just to make sure that we can extend a little bit. So I was in S6. I was like, now, these fellas are reading when they are in Makerere. Me, I'm here with nothing. So I started, that's when I started that mode of, because in that same talk, one of the classmates gave that idea of sleeping at 7 and when you wake up at midnight, no more sleeping. So I said, I got nothing, not even a certificate. This fella is already in Kampala, but he does not sleep. That's how I adopted the methodology of at 7 I'm in the bed, at midnight and that's it. Now I wake up at 4:30 to make sure that by 6:30 I'm here, no pressure. My adrenaline levels are low, my fuel gauge keeps a little bit stable because I drive straight when it's at night. No jam. But if you want to learn, I normally hear that stupid voice of TikTok. I want problems, I don't want peace. So if you don't want peace and you want problems, continue looking for problems. So, kindly work on this bit, okay? Of the source is going up, the current is going here. So our I4 prime should have been, prime should have been in this direction. And you would have, of course, if it is that direction, it will be negative by nomenclature. So that, therefore, our I4, which is equal to I4 prime plus I4 prime would be equal 6 milliamperes, which is equal to 2 milli. The Baganda say, "My nakuyo." That if you know your misery, then you work on it. And I tell you comfortably because I know you are not better. Even if you think your parent is better, you should have been doing some course down there. So don't brag around. I know that you are a survivor like me. I am very cruel. Some will say, but my dad is paying for me. You would be, that is on the money issue, you would be down there doing electrical or something. And this is about the working hard, same thing. So, you know your misery. And when you remove all those things, I pay for 4 of you. When they have arrested 2 of them. And he's using the new phone, and he thinks I'm not seeing him that he's doing that. Alex, you are using the other phone. Are you sure you are on something else? Because I don't think you can concentrate like that when you are on the We don't have time. I know you have a lecture after this. I don't want to delay the lecture. You have a test after. So I just want to give you the opportunity. I know some of you will always keep quiet. Let's not hurt him. But I can always see it on your faces that there is something wrong. So the other, on Tuesday I can use 30 minutes to emphasize the Tevenins, but that Tevenins, I am on YouTube video explaining it, both the one I did the standalone and the one I did in class. So if you want to really get it, but I will still repeat it to make sure that everybody is at the par, so that you don't say that man used to say this one you read on your own. I want to do my part, and then you do your part later. So we meet tomorrow for the Friday group at 3, and then the rest of you will meet on Tuesday. Alex, your phone. Emmanuel, your phone. You are doing from here? Yes. Let me disappear from here.